Welcome all. Now let us solve the first question. Determine the load resistance in ohms for a circuit when a maximum power transferred from the source of 80 volt to the load is 80 watts. Okay. Now we will solve this. First we will write down the parameters that is given in the question. First one, the source voltage, that is V is equal to 80 watts, and then the power, maximum power transferred from the source is 80 watts. So now we need to find the value of load resistance. Okay, this is the question. Since it is a direct question, we have, because we are having the direct formula, that is the formula for the maximum power transfer, that is P max is equal to VTH square by 4 into RTH. Okay, this is the direct formula. So here we need to find the value of RTH, which is nothing but the load resistance. So if we rearrange this formula, we will get RTH is equal to VTH square by 4 into P max. Okay, if we substitute the values, we will get the value of VTH is nothing but 80 volt. 80, sorry, here the value is 80. Okay, 80, that is VTH square, that is 80 square, that is 80 into 80 by 4 into P max is 80 watts. Okay, if we solve this, 80 will get directly cancelled. 4 ones are 420. Okay, so now the answer is 20 ohm, that is the value of load resistance is 20 ohm. Okay, so the answer is option 2, 20. Okay, hope you understood this question and how to solve. Okay, now we'll solve the second question. Determine the magnetic field strength in amperes turns per meter when the intensity of magnetization of the material is 0.78 amperes per turn per meter and the magnetic susceptibility of the material is 0.0013. Okay, I am once again reading the question. Here we need to find the magnetic field strength in ampere turns per meter when the intensity of magnetization of material is 0.078 ampere turn per meter and the magnetic susceptibility of the material is 0.0013. Okay, this is the question. Now we will solve this question. Okay, here the given intensity of magnetization, that is H is the intensity of magnetization. Sorry, here we need to find the magnetic field strength, that is we need to find the H, that is H is nothing but the magnetic field strength. So the given intensity of magnetization of material, that is I is equal to 0.078 and the magnetic susceptibility of the material is, the magnetic susceptibility is nothing but X. Okay, 0.0013. Okay, these are the given parameters. So now we need to find the H, that is magnetic field strength. For this we have in the direct formula, that is X is equal to I by H. Here we need to find the magnetic field strength, which is nothing but the H. So we need to just rearrange this formula. So H is equal to I by X. So if we substitute this value for I and X, that is 0.078 by 0.0013. Okay, so if we solve this, 13 ones are 13 fours are, sorry, 13 2 13 13 6 are, yes, 13 6 are 78, that is this 6 by 10 to the power of minus 1. If we take this to numerator, that we will get 60. Okay, so if we solve this, we will get 60 as the answer. So the answer is option A, that is 60. So just we need to substitute the value for magnetic field intensity and the susceptibility. If we just substitute and solve this the parameter, we will get the answer 60. Okay. I will solve the third question. What will be the value of magnetic field at the center of 7 meter long coil when the coil has 230 turns and carrying a current of 3 amps? Okay, I want to read the question. What will be the value of magnetic field, okay, at the center of a 7 meter long coil when the coil has 230 turns and carrying a current of 3 amps? Okay, this is the question. Now we'll solve this question. So the given are L is equal to 7 meter, which is the length, and N number of turns is 230 turns, and the current is 3 amps. Okay, now we need to find magnetic field at the center. Okay, that is B. We need to find the value of B. So for this, the formula is B is equal to mu Ni by L. Okay, this is the formula. See, it is in the exams they will not ask the question so critically. Just it is in a two-step process only. Just they will give all the parameters. Just we need to substitute the value. Just we need to know what is the formula, and just we need to substitute the values. So we can get the answer directly. So for that we need to know the formula first. We need to understand the formula, and we need to keep it in the mind of the all formula. Okay, now we need to substitute the value here. Mu is nothing but 4 pi into 10 to the power of minus 7. So 4 pi into 10 to the power of minus 7 into N is 230 and I is 3 by length is 7. Okay, if we solve this, 4 into 3.04. If we solve this, we will get 0.1246, which is nothing but 0.124. Okay, this is the answer. So the answer is option 4, 0.124. This is the answer for magnetic field. Okay, we will solve the next question. Determine the average value of alternating current in amps when the peak value of current is 14 amps. Okay, I'm once again reading the question. Determine the average value of alternating current when the peak value of current is 14 amps. So it is also a direct question. Okay, so the given is I peak is 14 amps. We need to find I average. So the equation for this is I average is 0.637 into I peak. This is the formula for I average. So if we substitute the value of I peak, that is 0.637 into 14. So if we solve this, we will get 8.92. So the answer is option 1, 8.92. Okay, this is the answer. See, it is a very easy question. Just when you hear, we need to know this derivation. That is I average is equal to 0.637 into I peak. So if you know this, we can directly substitute and we will get the answer. Okay, I will solve the next question. What will be the total impedance of a series RLC circuit when the resistance of circuit is 12 ohms and capacitive reactance of circuit is 3 ohms and the inductive reactance of circuit is 8 ohms connected in series with 220 volt 50 hertz supply. Okay, this is the question. Okay, so first we will write the given parameters, that is the when the resistance of circuit, that is resistance is 12 ohm and the capacitive reactance of circuit is 3 ohm. This capacitive reactance, that is, which is equal to Xc, is equal to 3 ohms and the inductive reactance of a circuit is 8 ohms, that is XL is 8 ohms. Okay, these are the given question. We need to find the total impedance. Total impedance is nothing but Z. We need to find the value of Z. So the formula for the total impedance is Z is equal to root of R square plus XL minus XC whole square. Okay, this is the formula. Since we are having the value for all this or XL and XC in the given question, here just we need to substitute the value here. So if we substitute the value for R, this R square plus 8 minus 3 whole square, that is root of 144 plus 8 minus 3 5 square is 25. So root of, if we add this 169, so the root of 169 is 13. Okay, so the value of Z is 13. So the value of impedance is 13. So the answer is option 3, 13. Okay, this is the answer. Okay, now we will solve the next question. Last and final question. Okay, determine the capacitive reactance of series resonance circuit when the circuit is supplied with a frequency of 50 Hz and having a capacitance of 0.04 millifarad. Okay, this is the question. Okay, now we will solve this. So here we need to find the capacitive reactance, that is Xc. We need to find the capacitive reactance Xc when the circuit is supplied with 50 Hz, that is frequency is 50 Hz and the capacitance is 0.04 millifarad. Okay, these are the given. So the formula for identifying the capacitive reactance is X is equal to 1 by 2 pi Fc. Okay, this is the formula. Just need to substitute here. So if you substitute this, 2 into 3.14 into frequency is 50 and the capacitance value is 0.04 into 10 to the power of minus 3. So if we solve this, we will get it as 79.621. Okay, so the value of X is 79.621. so the answer is option 2, 79.62. okay, this is the answer.